Today is the second day of the Smart Traffic Middle East Conference. So we hope that this second day will be as fruitful as yesterday. Yesterday we had exciting topics about the future of traffic, the future of mobility, the future of transportation. And today we have also some exciting speakers from the industry, from the government, and it's really interesting. And I have one remark for you, especially people from the industry. I come from futurecitiescouncil.org, which link business to government, to academia, to the citizen. So we have a lot of opportunities, projects, and we link the customer to the supplier in the field of smart cities. And one of the pillars of smart city is a smart transportation and mobility. So please send me an email so I will register you as a member of this organization, and you get all about smart cities with all its pillars. And you get the news, you get the projects, opportunities, and so on. So let's start our second day with an exciting topic from Mr.Ashish Agrawal. Mr.Ashish Agrawal is the director of Transpo Group UAE. He's going to talk about self-driving public transportation practices and opportunities. So please have the floor. Thank you.
Thank you very much. All right. For those who I have had a chance to meet with, my name is Ashish Agrawal. I'm a director at Transpo Group for Autonomous Vehicle. We had an opportunity to work with RTA to develop their strategy and roadmap for the self-driving transport. And really it was an interesting project in that we had opportunity to look at not just the technology, but really also focus on the building blocks, the legislation, the insurance, infrastructure, all those kind of interesting things that go in the background to enable the self-driving transport. Today, the topic is the self-driving transport and the public transport. And really, the question is, are these two competing for the same space, or are there opportunities for self-driving transport to really bring up the public transport in the region? So we look at this question. It's not an easy question because the technology itself is moving very fast and at an unknown pace. So we want to look at this question in a multi-layered way: how the technology is moving and how the public transport could stand to gain or could actually be even hurt with it. So to begin, I think there's a lot that has been said about the autonomous vehicle in this conference, but I want to set the framework because a lot of terms have been used: autonomous vehicles, self-driving cars, or the autonomous cars, and what do we really mean by them when we use those terms? Society of Automotive Engineers in the US, they came up with this framework, taxonomy really, to lay out the framework how these functionalities or automation of vehicles is coming up. So starting here at level 0, what you have is a conventional car, which really means that there's no assistance to the driver, and all the way till level 5, where you have a completely driverless car which is able to drive itself. And in the middle, you've got the varying level of automation. Level 1 and level 2, you've got the driver assistance. So really, the vehicle is able to warn the drivers if he's veering off the roadway, or if he's coming up too close to an object on the highway, and things like that. And then level 3, when you get to that, that's really when you have the conditional automation. And really what that means is that the vehicle is able to take over for certain duration and for certain use cases. So it could take you from an on-ramp to an off-ramp on a highway, but then it will turn over the control back to the driver. Level 4 is when you have the vehicle driving itself, but still has the control for the driver. So it still has the steering wheel and all those controls that are required. And level 5 is really the ultimate goal here, where you can have the the vehicle driving itself from point A to point B. There is not even a steering wheel, no control for the drivers at all. So you're just sitting in the car and the vehicle is taking you from your origin to destination. So that is the framework. Now we're talking about public transport here, and we want to see how public transport fits into this framework. Obviously, different modes have different constraints and opportunities. So they all have different kind of a automation level right now. So as you can see, the taxis and buses, which are really running on the roadway without much guidance, have the hardest time because they have to deal with a lot of traffic and all these complexity on the street. So they are running right now at around level 2, which can have some assistance to the driver, but not really automated. When you get to really level 4, there are shuttles that can run at low speed, but can run themselves for a certain duration of time. So that is really the framework. This is where the technology is right now. Well, what I see now is what are the technologies within this level of framework that are enabling these kind of automation. So again, level 1 and 2, and also partly level 3, you're looking at a lot of driver assistance. You have automated braking, emergency braking. If you have any chances of forward collision, the vehicle can give you warning. But in most of these cases, the vehicle is only alarming the driver. They're not really controlling the driver as much. They're not controlling the vehicle. They're just providing this kind of alert so that the driver can act accordingly. Level 3, there are some use cases now. The most popular one right now is by Volvo, a Drive Me program in Sweden, Gothenburg, where they're able to, or they're testing right now, to go to level 3 and have the vehicle drive from on-ramp to the off-ramp on a freeway, mixing with the live traffic. And that's a real test that they're planning right now. But that's the level of technology right now in terms of the automation. Level 4 and 5 really are the technology for future. And there's a lot of challenges that have to be overcome. Not just the technology, but also legislation, insurance infrastructure. There's just so many of those constraints right now that have to be overcome for us to get to that point. But in terms of again, public transportation, really the opportunity for public transportation is multi-layered. So when we're talking about level 1, 2, and 3, partly 3, the opportunity really is in the safety and in the journey time reliability. So basically, in these cases, as I said before, you have the vehicle alarming the drivers. So you have the opportunity to make it safer and have improved journey time reliability. So that is the benefit in the initial levels. And then level 3 and 4 is where you start to see some modal shift to public transportation. This is where you have some first mile to last mile connections and some additional journey time reliability and more comfort and convenience for the passengers, so they can go from their origin to destination with a continuous path on the public transit. Level 5 is and part of level 4 is where you start to see a paradigm shift, as some of us heard Uber without the dude sort of thing, where the on-demand public transit can pick you up from your house or your origin and take you all the way to your destination. And on the way, it can stop at different stations. It could even work like a horizontal elevator, where you get on any point that you want to, and the elevator stops only if you press that button. If there is nobody there, it doesn't stop, so you can continue that way. So there are many models, and really also the shared ownership model comes into play, where people don't necessarily have to own cars. They can just share cars with some people. So really a lot of economy of scale come into play. So these are 3 different stages. We're going to go into a little bit more detail on 3 of these stages as to what is the benefit specifically for public transportation. We'll start with the use cases for the level 1 and 2 for the safety benefits. But what's important to note here is that the level 1 and level 2, because the driver is still a key element to the driving experience, because the vehicle is not able to take you from your origin to destination, driver attention is really key. If the driver is not paying attention, it could get into a crash very easily. So imagine if you are in a car and it's driving itself, and that allows you to focus on other tasks, maybe eat something or write or do something, read something, and suddenly the vehicle cannot go any further. Now it wants you to pay attention. In that case, it's not easy for the driver to take control right away. First of all, the driver needs to be aware with the situation, and it takes about 8 to 10 seconds for the driver to understand that these are the things that are going around me, so I need to control the vehicle in a certain way. So these are really important things, especially for the driver. So in level 1 and 2, the safety benefits are not very trivial. It seems like, yes, you can have the vehicle self-driving, all these technologies can improve the safety, but it requires a lot of training for the drivers. And if they're not trained, it could actually be detrimental to the safety. But this is where the opportunity is for the public transit, because the drivers for public transit are controlled by the government, and they can be trained and they can be really regulated and controlled, so they behave in a certain way. So then you start to unlock the benefits, especially the safety benefits in level 1 and level 2 and part level 3. In fact, the benefits with the public transport are so much that we believe that the public transport level 2 and 3 will actually take over the private cars. So these public transportation will have faster growth in terms of the self-driving technologies. But then, now let's look at some of these technologies that are important for the level 1 and 2 and part 3. Lane keeping assistance, collision avoidance, emergency braking, and departure. As you can see on left, these are the use cases for public transit. So on the left you have a tram scenario where the tram is able to detect a vehicle on its path and is able to stop. Now the driver will be trained, so he will be able to manage the situation properly. The same thing on the right, you see a bus being able to act accordingly and stop on time to avoid the collision. And these benefits again are really, they come to fruition especially with the public transportation. So that is really the main selling point for public transportation is in the initial stages. And the benefits really, if you look at the kind of crash reduction factors that you can see, the studies have shown that all of these kind of technologies can really reduce the traffic, the crashes by a lot. So you have the emergency braking system that could reduce the rear end crashes by 35%. Lane keeping assistance that can reduce the accidents 37% on the merge situation. And then also you have the road departure and forward collision warning system. They also can contribute quite a bit on the safety side. So that's again the initial stages where you have just the warning systems and some initial technologies. But as we move forward to the next levels where you have level 3 and really the safety benefits would have been realized to the most extent, and then you start to see these kind of the modal shifts. And really what we think is going to happen is the first mile, last mile connection. And a lot has been said about that here as well, in that when you have these kind of connections, that really allows people, really make them gravitate towards the public transport, because now they're able to go from their point A to point B instead of just doing their part of the journey on the public transport. And also the journey time reliability goes up with the connected cars and the way they're connected with the infrastructure and system. And obviously the other thing also is the passenger comfort. So when the car is driven by itself, by the system, there's a lot of passenger comfort that comes into play, because the vehicle will be controlled in a very predictable and a intuitive way. So the passengers will feel the comfort, and this will drive them towards the public transportation. So that's level 3. Moving on to the next one, which is really where we think, and we've heard of a lot of studies saying that there's going to be a paradigm shift where you start to see people really moving from the private cars to a shared ownership type of a model. The benefits that could be realized potentially are huge. So really what you're looking at here is that for every 9 cars that are running today, you would need 1 car that would be able to serve the same number of people. Yes, the mileage traveled could go up a little bit because the car would be traveling empty, but then the benefits are so much that could outweigh those kind of extra mileage. Now, yes, there is a case for these kind of Uber without the dude sort of thing, but what we think is that the mass transit, the metro and the tram and the buses are still going to play a key part. So yes, part of the public would start to use these kind of technologies and have a shared ride, but then the tram and the metro, those are not going to go away because they have tremendous benefits in the way that they can move mass people. So yes, a lot of people could use these. And also the other thing also is here is that before we could get to this level 5, there's a lot of work that has to be done, all on the technology front as well as on the all the building blocks in the infrastructure, legislation, all those kind of things. So we're looking at a really long time before we can actually get to this point. So the point here is that with all of this, the public transport really stands to gain quite a bit of ground, especially in the initial stages where they're able to make themselves safer, more attractive to the people to come and ride them because they're able to take people from A to B. And also, as you go to level 3, there are some benefits, and the benefits will continue to the third stage 2, level 4 and 5. Now, one question that I often get asked is that what happened in the last 4 or 5 years that we've seen a lot of tremendous growth in the self-driving transport. Everyone seems to be talking about it in the last 4 or 5 years. What really happened? And really answer is, at least there are 2 things that we can put our fingers on. One is the big data. So in the last 4 or 5 years, really the big data has exploded and really has enriched our lives. We're able to get so much of data now. The second thing is the computing power. So really now we have the capabilities to process huge amounts of data, which wasn't possible before. And really where these 2 things meet, the sweet spot for these 2 things is the deep learning. What's happening here is that now we have all these kind of data and we're able to process all this data to make some meaningful inferences from this data. So deep learning is really the engine right now that has happened in the last 5 years. If you think about 10, 15 years ago. 15 years ago when I did my master's, I was doing in my computer vision. I was trying to detect cars from aerial images, and we were able to do that using feature detection, which was the technology that was going on at the time, but it was extremely hard, and you have to write a lot of rules to really detect those cars from the images. So when we did that, we used images in Arizona, and we detected the cars, and we were quite accurate. But after that, after we were successful or we were satisfied, we then had a chopper really literally flying over a street in Washington, and we got the footage from there and we ran the same algorithm to those footages, and the results were just not there. The technology, the way people were processing information was just not really there. And so from there, now if you look at the deep learning can really do wonders, and it can really detect objects. And that's really what's powering a lot of this technology. So I'm going to spend a little bit of time to explain what deep learning is, how it works, and give you some examples and really show you how it really can change transportation, and it's going to change whether we like it or not. So really to start with, the way deep learning works is that it's really based on the way our brains work. The way brains work is that you have a first set of neurons, which is really triggered when you have an edge at a certain angle. So one neuron might be linked to a 45-degree angle. So when it sees something at that angle, then it gets triggered. And the next neuron next to it will get triggered at, let's say, at 50-degree angle. And the next level of neuron, when you get to it, they start to make features. And then as you get deeper and deeper in the neural network, you start to see a complete picture. And that's the thinking that has been used now in the detecting objects. So if you see at the top, there's a car there that you can see at the left side. And really what the program is able to do is to break down this image automatically into smaller pieces. And really the point of the second image, is which you see all the edges, is that if you just use that image, it's able to construct the left image all by itself. You don't need any more information than what you see in the second image from the left. And when you start combining it and you use some convolutional neural network, you start to make feature and feature after that, and so you get to the right side where you're able to detect objects. For computers, it's not really, there's no difference between a car or a face or anything like that. So you can use the same technology, the same algorithm, and that's the beauty of it. You don't have to write different codes to train it to detect different types of objects. So now you're able to do the same thing with faces, with cars, with elephants, with chairs. It doesn't matter what kind of object you have, but you're able to detect all these kind of objects using the same algorithm. Yes, you need a lot of data, and this is where, again, the big data and the computing power has come into play, because you're able to do that. Now, using the same object detection, now let's go a step forward. So now you're able to do an object detection from your car, and now you're able to see all these different kinds of objects from your car. And here again, this can be done all real time, which was not possible even offline before, and now you can do it all real time. I'll give you a small this is a real time detection that's now possible, and you can see how the vehicle, as it's moving, is able to detect not just the cars or a pedestrian, but almost any object that you would like it to detect. And you put that on a HD mapping right now, then you're able to really make a sense of what is out there in the world, and you're able to detect and have the vehicle move forward. And so again, going back to the self-driving thing, this is one of the key breakthrough that has been possible in the last 4 or 5 years, that has really powered a lot of research into how the self-driving can work. Now, what does it do for the transportation other than the self-driving? Because self-driving, like I said, does require a lot more testing and a lot more development. So there are other applications that this can be used, which is other than self-driving transport. So the examples that we have is, for example, we have right now a lot of CCTV camera feed coming to the control room, and not much really is being done with it, because really practically we cannot do anything with it. We don't have enough manpower to do anything with it. But with this kind of object detection, you're able to now detect cars, track them, or detect pedestrians, or track them across the different cameras. So the possibility to detect cars and objects is there now. The other thing you can do is at the traffic signal. Now you can detect the number of pedestrians at the signal. So you don't have to just look at the sensors and see how many vehicles are coming to the junction. You can now actually count the number of pedestrians and then optimize the traffic signal accordingly. You can also have more predictive. So the way the traffic signals are optimized right now is really, an age-old technology now. So now we're able to do the optimization much more accurately. So the opportunities are endless. What I want to leave you with is that the technology is moving at a fast pace, and we have to think beyond just the traditional ways of technology that we're looking at. That you've got some sensors, you try to make some sense of the information, you integrate it with the backend, and you control the traffic this way. We can really do wonders, especially in the incident management and controlling and predicting the travel behavior. That's all. Thank you. Any questions?